In this problem, we are given a circuit diagram right here. We need to use the node voltage method to find how much power the 2 amp source absorbs or delivers in this circuit. I have provided an example right here of the node voltage as well as the equations that we use to actually solve this. If we did these steps, we would end up solving for this circuit diagram. And the reason I provided it is just to cross-reference everything that we're doing and make a variation of these steps. First thing we're going to do is step 1, which is define our nodes. We can see here that we only have one main node right here, and we also have a ground node right here, but that's not important right now. So that means we're going to have a plus minus for our voltage like this. This will be V1, and then we'll make this V2 with a plus minus like this. We know our voltages go into our plus and out of our minuses. So the first thing we're looking at is at our node 1, which is this is our node 1, the voltage across the first resistor. When we look at this, we're given a current right here. But there is no resistor for this to cross. There's no resistor here. So that means we can actually omit this first part. We don't have anything like this, so we're not going to use it. But what we do have is a V1 over our R1. And we know it's going this way, out of our node. So we're just going to have our V1 over the 50 ohm resistor. Then we have a plus, and then we want our V1 minus V2. This is because we have our resistance right here, and then we have the voltage that follows it right here. There is something to note though. There is a resistor right here and a resistor right here. These two resistors are connected in series, so that means it's going to be equivalent to a 5 ohm resistor. So when we do this, we're going to be putting it over a 5 ohm resistor instead of a 1 ohm resistor. And then we're going to have a V1 minus our V2, but we know our V2 to be 45 volts, so we'll do V1 minus 45 volts. And this is equal to, well, normally it's equal to a 0. However, we can see that the current going into our node from this 2 amps, like this, is going to be 2 amps. So this is equal to 2 amps. We're basically saying what we have here and here is the current formula. We know the voltage formula to be voltage is equal to current times resistance. If we rewrite this, we can see that voltage over resistance is equal to current, which is what we have right here and right here. And what we're saying is that the current going through this resistor and this resistor must equal this original current. Since at this node it splits in parallel and current through parallel is divided. It's dispersed depending on the resistance. And that's basically the way we're writing this equation. We only have one unknown in here, so we only need this one equation to solve for it. I'm going to multiply everything by 50 ohms to get rid of the denominator. And after I do that, I'm going to get a V1 plus a 10 V1 minus a 450 volts is equal to 100 volts. Now we're going to combine like terms, so we'll have 11 V1 is equal to 550 volts. We have 550 divided by 11, and that's going to give us that V1 is just equal to 50 volts. This is the voltage flowing through V1. And since we noted that at this node, our circuit diagram is in parallel, the voltage is the same throughout. That means that the voltage at this 2 amp current right here, it's going to be the same as our voltage in V1. So we're just going to write V1 right here. It's the same for these two. Again, since they are in parallel. So what that means when we try to calculate the power at our 2 amp current, we're going to say P2A is equal to the voltage times current formula. And we're going to get our voltage as 50 times the current, which is 2 amps. So that means we're going to have 100 watts of power. And this is the answer for this problem.